In the previous lecture we discussed about till c minus 3. Now the continuation. So this is Cn, and now c minus 3 we discussed. Now c minus 2. What is c minus 2? You substitute the value of n here, that it will become n is minus 2 here, you will get sine of minus 2 pi by 2 by minus 2 pi, and it is 0 only. Okay. Now c minus 1. So put n equal to minus 1 here. So sine of minus pi by 2 by minus pi, you solve this, you will get minus 1 by pi. Okay. Now c0. In c0 you can put here. Why? Because 1 by 0 it will become infinite, so you have to put in the general equation 1 by t minus t by 4 to t by 4 e raised to minus n omega t. In that equation you have to put n equal to 0, you will get minus t by 4 to t by 4 dt, that means t varies from minus t by 4 to t by 4. So you substitute upper and lower limit, c0 you will get the value 1 by 2. Similarly for c1, c1 you can substitute here. Why? Because n is 1 here, so 1 by pi sine pi by 2, 1 by pi, that is sine pi by 2 by pi, which is nothing but 1 by pi. Because this is sine 90, no, sine 0 1, sine 90 is 1, sine 0 0, sine 90 is 1, so it is 1 by pi. Now c2, find this value. C2 will get 0, for c3 you will get minus 1 by 3 pi. Substitute all these coefficient value to this general equation, you will get a term like this. S of t is equal to first is c minus 3. See, first is c minus 3 e raised to minus j3 omega t. So c minus 3 is nothing but minus 1 by 3 pi. So minus 1 by 3 pi e raised to minus j3 omega t, e raised to minus j3 omega t plus c minus 2. Substitute the value of c minus 2 here. So 1 by pi e raised to minus j omega t. Now what is c minus 1? C minus 1 is 1 by pi. So 1 by pi e raised to minus j omega t plus, now c0 it is 2, 1 by 2 plus, it is c0. C0 it is 1 by 2, then c1 e raised to j omega t. What is c1? C1 is 1 by pi. So 1 by pi e raised to j omega t. Next is c2. What is c2? C2 is minus 1 by 3 pi. Minus 1 by 3 pi e raised to j3 omega t, like etc. You complete this equation. Okay. Complete this equation. Then now look at here. From this term, these two terms, sorry, this term and this term, compare this term and this term. Minus 1 by 3 pi, minus 1 by 3 pi, e raised to minus 3j omega t, e raised to plus 3j omega t. Take minus 1 by 3 common from these two terms. So minus 1 by 3 e raised to 3j omega t plus e raised to minus 3j omega t. Plus, take these two terms, take 1 by 2 common. So 1 by 2 e raised to j omega t plus e raised to minus j omega t, plus remaining is 1 by 2 plus 1 by 2, etc. So this you can write as cos omega t. Okay, cos omega t, you know what is cos omega t, e raised to j theta plus e raised to minus j theta. So it is cos omega t. So omega is nothing but here 3 omega. So instead of theta we put 3 omega t. So minus 2 by 3 pi cos 3 omega t plus here it is, here also actually e raised to j theta plus e raised to minus j theta by 2. So 2 is not here, so we put it a multiplied 2 here. Okay, to compensate that. Similarly here also denominator we need a 2, so we need to multiply a 2 here. So that's why a 2 here. Because explain the cos equation, a denominator 2 will become that 2 will cancel out, you will get the original equation like this. So this is 2 by pi cos omega t. Now 1 by 2 remaining, that you take here. Now by the equation v2 of t is v1 of t into m of t. What is m of t here? M of t here we choose it as s1 of t, s of t, right? In the equation, see, listen here, we know that v2 of t is v1 of t into s of t. Okay, so v1 of t is nothing but, so v2 of t is v1 of t into s of t. v2 of t is v1 of t into m of t. What is m of t here? S of t only, no? See, what is our V2? This is our V2. V2 is nothing but V1 of t into S of t. What is V1 of t? Multiply this 2 will multiply, you will get V1 of t. See, what is V2 of t? V1 of t into S of t. What is V1 of t? This you V of t, M of t, this is the combined effect, you will get V1 of t. So what is M of t here? M of t is nothing but S of t. Okay, what is S of t? We already found out S of t is this. Okay, this is S of t. So the question, finally we need to find out V2 of t. V2 of t equal to V1 of t into M of t. So what is V1 of t? M of t plus AC cos omega ct. That is our incoming signal. What is M of t? M of t is something but S of t only. S of t we already found out, 1 by 2 plus 2 by cos omega ct plus minus 2 by 3 pi cos 3 omega. Omega, here it is omega in this. Here we consider omega as omega c. That's why I am writing, instead of this omega I can put omega c, because I am taking at omega c. So 1 by 2 plus 2 by pi cos omega c minus 2 by 3 pi cos omega ct plus etc. Okay, you just cross multiply with each and every time. M of t by 2, 1 by 2 multiply to all these times. So M of t by 2 plus AC by 2 cos omega ct. Now this time multiplied by whole time. So M of t into 2 by pi cos omega ct plus, now this time 2 AC by pi cos omega ct cos square omega ct minus this time multiplied by these 2 times. You multiply this time with this 2, so minus 2 M of t by pi minus 2 M of t by 3 pi cos 3 omega ct minus 2 AC by 3 pi cos omega ct into cos 3 omega ct. Okay, now rearrange this. Cos omega ct times, you take cos omega ct time. Here we have a cos omega ct time. Here also we have a cos omega ct time. You take 2 AC by AC by 2 you take common, but here AC by 2, here no AC by 2, so you have to multiply 2 by AC, like that. So AC by 2 you take common from these two terms, you will get here AC by 2 cos omega ct, this is you are taking outside. AC by 2 cos omega t you take outside, let this become 1. So 1 plus 4 by pi AC M of t. See here also AC by 2 cos omega ct I am taking outside, then the remaining is 4 by pi AC here. M of t cos omega ct plus M of t by 2 remaining plus these 3 terms. That is here. Now the thing is, the last stage we need to, what is the last stage here? A band pass filter. The output is passed through a band pass filter with a frequency omega c. So here I am taking omega c as the cutoff frequency. Till omega c it will pass. Okay, like that. It will pass only nearer to omega c, not till omega c, nearer to omega c. See, because it is a band pass filter will pass only certain range of frequencies which is very nearer to omega c. Now let us check this equation. In this equation, what are the components which will pass through this band pass filter? ഇതിൽ കൊടുത്തിരിക്കുന്ന ഏതൊക്കെ components ആണ് band pass filter പാസ് ചെയ്യുന്നത്? ഒമേഗ സിക്ക് അടുത്തുള്ളതിനെ മാത്രമേ പാസ് ചെയ്യത്തുള്ളൂ. ഓക്കെ, നോക്കൂ, ഇതിൻ്റെ ഫ്രീക്വൻസി ഒമേഗ സി, സോ ദിസ് വിൽ പാസ്. ഓക്കെ, what about here cos square omega c? Here cos omega c into cos 3 omega c. That is a problem. The first term of the above equation represents the desired AM wave and the remaining terms are unwanted. Thus, with the help of band pass filter, we can pass only AM wave and eliminate the remaining terms. See, look at here it is omega c. Cos square omega c, you can write as 1 plus cos 2 omega ct by 2, like that. Cos square theta is 1 plus cos 2 theta by 2, like that you can write. Then it becomes cos 2 omega ct. That means double of the omega c, that will not pass by our band pass filter, because it will pass only omega c. When 2 omega c comes, it will not pass, like that. Here 3 omega ct will not pass, here also 3 omega ct will not pass. Okay, here DC only, so it will also not pass. So what will get at the output is this term only will get at the output, because cos omega c it will pass. So AC by 2 1 plus 4 by pi AC m of t cos omega c t. This is the standard, compared to the standard equation, AC into 1 plus Ka m of t cos 2 pi f c t. This is the standard equation. So we got the modulated signal from the switching modulator output. This is the switched modulator output, modulated wave. So by comparing with the general equation, we can call it as Ka. Receiver sensitivity is the Ka. So here Ka is nothing but 4 by pi AC. So Ka equal to, sensitivity Ka is 4 by pi AC for switching modulator. This is the derivation for switching modulator.